Hello, hello. Welcome to Hoot episode 42. Today, we're going to talk about Rust-based Ztunnel for Istio Ambient Service Mesh. If you recall, when Istio Ambient Service Mesh was announced in September 7th this year, 2022, the Ztunnel, which stands for Zero Trust Tunnel, was implemented using the Envoy proxy. So what was the thought process when evaluating Envoy was Rust-based Ztunnel? And what are the key considerations? I am so excited today. Kevin is joining me to explain the thought process. And we will also give you guys an update on Ztunnel latest development. So as always, thank you so much for joining us. And please let us know if you have any questions in the chat. With that, I'm going to pass the mic to Kevin. Why don't you introduce yourself to the audience?
Hi, yes. Thank you for having me. This is, I can't believe it's already our 42nd Hoot. You could call me a long-time follower, first-time host over here. I'm one of the tech leads here at solo.io. I did some of the testing work initially for Ambient Mesh on Amazon. I'm definitely involved in the project, and we can talk about why certain decisions were made recently. So excited to share the insights we have.
Awesome. Thank you so much, Kevin. So let's briefly get to the news. Unfortunately, I didn't have a lot of time to prepare for the news. The first thing I want to mention, in case you missed it, we have a Ztunnel project in the Istio org, and this is the new Rust-based Ztunnel. Essentially, the Istio community is investing very heavily in the Rust-based Ztunnel. And recently, I believe it was last Monday, yes, Kevin and I actually published a blog on the thought process of how Solo as a company deciding and join the community on Rust-based Ztunnel for Istio's ambient service mesh. So Kevin, do you have any news in mind?
Yeah, the only thing that comes to mind, I saw recently that Amazon it's getting back into the service mesh space. They had app mesh, and now they've got this new VPC lattice thing. Still working on the details. It seems pretty new, but it's exciting. Check it out. I love seeing service mesh being adopted kind of across the industry.
Yeah, it's definitely a very exciting area. Thanks for sharing that news, Kevin. So with that, I would love to kind of start a discussion with you. The first question I have, Kevin, to you is, why did we start with Envoy-based Ztunnel initially in September and also before September, right?
Yeah, well, I think the first reason is that it was, for starting ambient mesh, we had the high level designs, the objectives, what we thought it would look like. But in the implementation days, it was very much like a almost not POC level, but we knew it was alpha. We wanted to get something that people could test and look at quickly. And to that end, we thought Envoy was probably the quickest way we could get there. We already had the infrastructural investments around CI/CD, familiarity on both the developer and the operator side. And in doing so, we would discover things that we maybe didn't anticipate, and better to do that in something that's like battle hardened and we know well. So yeah, it felt like Envoy was like a natural first choice until we discover otherwise.
Yeah, and now that you are talking about this, so for folks, if you guys remember, in this blog, we actually talk about some of the challenges of Envoy. Maybe I'll pass on to Kevin to talk about that next.
Yeah, so I think the first part that you've got highlighted here, we're talking about some of the reasons we liked Envoy initially, right? We covered
Yeah.
CVEs in the long term as well, things like CVEs and shared code. If we could use Envoy again, we have to do extra work. The customer onboarding I just talked about, we could be ready in production faster. But yeah, in doing so in this alpha phase, we knew that there would be complications too, some difficulties. The Envoy implementation for ambient mesh is pretty complex under the hood. This is largely because of Envoy's design, but decisions early in the project where it was designed to be multi-tenant, each thread be separate, and we'll get more into that. Separate memory. We'll get more into that in a bit. But the kind of result here is that the Envoy configuration for Ztunnel is actually quite complex. If you ever did like a proxy config dump on Envoy and the alpha release of Ambient Mesh, you'd see, n squared plus, configuration for, per pod abstractions. The cluster listeners, those common Envoy interfaces are very much meant to be per tenant. But here, Ztunnel is really kind of a multi-tenant proxy. It's responsible for proxying traffic for tons of different identities, anything on the node. And so when let's take an example like the Envoy cluster, you got to pick your MTLS certificate to use. You might change the cert depending on the destination. So you have to have Envoy pre-configured with every cert that it might need. And also if we use, an internal listener in the implementation to defer the load balancing decision based on whether we need to use HBone or not. So another example is exactly that. We need listeners listening for whether it has the protocol or not. And each one of these kind of decisions that we have in the implementation, which is explained in more detail in this blog and in some of the articles underneath. But kind of in short, the configuration gets very large. It leads to lots of CPU and memory usage, and as we saw, perhaps some performance issues as well.
Yeah, I remember at one point before Ambient was launched, whenever we need to debug Envoy-based Ztunnel, we comes down to like the control plane for Ztunnel becomes so complicated. It's just so hard to troubleshooting any single type of problems, and then we really have to type people who are really, really expert level at Envoy, either at Solo or sometimes at Google. So it was super, super hard. And like Kevin was mentioning, I guess the config dump was complicated. I think the logs was also pretty complicated. Like the access log for Ztunnel, Envoy-based Ztunnel was a little bit hard to read because of the internal listener, because of the traffic jumping a bunch of hoops even within the Ztunnel. Yeah, it was definitely complicated. So, Kevin, the next thing I want to ask you, I remember at one point, even though we talk about complexity of Envoy, right? We talk about a lot of things we love about Envoy as a company. Solo is entirely built on top of Envoy initially with our Glue Edge product, right? So at one point, you were convinced that Envoy was the right approach for Ztunnel. Because a couple of reasons. I'm just trying to understand, what's changing your mind.
Yeah, so kind of to dig into that thought process further, yeah, I was pretty convinced that Envoy would be the right choice going forward. I know that we talked a little bit about how Envoy's multi-tenancy kind of assumptions in design were problematic to the Envoy config dump and likely the processing and the number of listeners, clusters, everything like that. Part of this evaluation was kind of evaluating how could we have solved those problems if we wanted to use Envoy, right? And we did. There was an exercise, done, public in the community. Google contributed heavily. Solo was involved, and part of this is, we could have used special custom listeners and routing filters. We detailed ways that we could simplify Envoy to make this work without a configuration explosion, and looking at that, it seemed pretty reasonable. Like the end result with a custom listener, a certificate provider to let you kind of live swap the cluster MTLS configuration seemed pretty reasonable. It felt like Envoy was pretty naturally doing what we wanted as a multi-tenant proxy in that imaginary final state. But and we would get the CVE's common code. We'd already familiar with it. We didn't have to redo CI/CD. Developers in the community don't have to learn Rust or a new language. But the question really came down to a concern brought up about work stealing. So this is kind of what really changed my mind personally. The really short argument is that we wanted to support, I'll talk more about what work stealing is, but basically if we didn't do it, we didn't think Ztunnel could perform as well as it could. And it's not really easy to bring work stealing to Envoy. So I don't know if you want me to dive into that more deeply
Please.
now.
So for the folks who are not familiar with work stealing, can you first explain what it is?
Yeah, so the idea behind work stealing is, if we think about just computer architecture in general, you have a certain number of hardware threads operating on cores on your machine. This is true on your laptop or out in the cloud. Now, the idea is that they're probably not all threads are busy. You can do a lot of work simultaneously. if one is not busy, you can steal someone else's work and be more efficient. That way, none of the threads are, lazy or not doing anything. The assumption baked into this is that memory can be shared across these threads, or else it can't properly steal the work and do it. The problem with Envoy's threading model is that it does not share memory across threads. It was kind of intentionally designed to do like copy memory to thread local storage. Each worker thread operates, on its own copy of the memory. They're not shared intentionally, which makes the code a lot easier to write, especially for complex like L7 policy, like implementation, filters, things of that nature become a lot easier, perhaps even more performant. But in a multi-tenant case where we want to support work stealing, it does not work. We've got some diagrams here to.
Yeah, would love to see them. So just to clarify one thing for our audience, when you talk about work stealing, you're talking about one thread starts a job but hasn't fully finished the job, right? And then some other thread comes in.
Lynn, did we lose you or did you lose me?
Yeah, so sorry, I went away for a second. I think I pressed the wrong key. Somehow I was exited out of StreamYard. I apologize for that. Kevin, you were sharing the screen.
Yeah, and then I thought I broke things. But here, let me share my screen again. I think it'll help to
Yeah,
take a look at
please
work
do that.
stealing and the threading model.
Yeah, because the question I was trying to get at, I think it's important to understand what you are saying is for the jobs that's in the middle, right? And then for another thread to kind of take over that existing job, right? And then be able to continue with that job without like restarting everything because it was able to reuse the memories from a different thread. Is that a good way to put it? To
Yeah,
understand.
I would kind of separate it exactly. It's a pretty good way, and I think this diagram pictures it pretty well. It's in the diagram here. You've got this thief who's Q2 is
Do you
not very
want to
busy
enlarge
here.
it? Maybe go
Sure.
to slideshow mode. Yeah, that's
So
perfect. Thank
yeah,
you.
here we have Q2 is empty, and it on a runtime can steal the work of job 3 and put it over here. It kind of operates at a different level. It requires a runtime scheduler. So in this context, we might have a single thread pool trying to share all these queues and jobs. I just want to be clear that this is operating at a different level of the kernel scheduler and processes and threads. The kernel is limited to number of hardware threads that you have, and each context switch is very heavy. So we try to avoid those very aggressively. And to do work stealing properly and be highly performant, we want to keep things very light, keep the jobs quick, and let the runtime layer on top of a process handle that for us. It can scale to more threads and workers than we have hardware threads, and we can avoid context switches by having a runtime do scheduling on top. But kind of in our ideal scenario, if we want to maximize performance, we want to have a single thread pool shared by all of our kind of workers, and then be able to steal work when they're not busy.
Okay, got it. Can you also, just to contrast things, can you talk about how Envoy works today? I assume it's without the work scheduling.
Yeah, so it has none of that. That runtime scheduler can be done in Rust. It's got the Tokyo library. There's C++ equivalents like Boost, but out here in Envoy land, the way it's implemented today is kind of pictured here. On the left, we have the main thread, which handles XDS, stats, admin, process management. The main thread does everything but handle downstream requests. Each worker thread, has the listers and connections. It has its own copy of everything, including memory. And so you have your main set of memory. This is thread local storage, TLS. And so when you're writing Envoy code or you're in a filter here, whenever you want to get memory from thread local storage, it copies it to its own copy of memory. It gets like a read lock, copies the 3 in, whatever's in memory bucket 3. And each worker has a copy of the memory that may or may not be completely up to date, but it can always use its copy of the memory. Further, each worker thread in Envoy has its own thread pool. Which means that they can't be shared across. And if we go back to our ideal scenario, we prefer one thread pool and have that shared, have memory shared versus the way Envoy works today. So just kind of as a necessity of supporting work stealing, Envoy is really kind of far from that.
Okay, so I guess the next question would be, why is work stealing so important for Ztunnel, right? Because we've been using Envoy for a long time in the Istio project, right? We use Envoy for sidecar. I mean, we're going to continue to use Envoy for waypoint proxy and also gateways too. So why is it so critical to Ztunnel?
Yeah, so it really all boils down to engineering trade-offs. So, I'd like to highlight how important connection reuse is in Ztunnel in a second, but I think, if we think about the ideal for work stealing here, other assumptions built into doing this properly, when you implement a work stealing runtime or scheduler, there are still locks. You still need to lock on lots of the memory that's shared. Um, and it's only performant if the jobs themselves that we steal are very quick, if they're very small, so that we can stealing that is effective and the things are waiting. If we think about complex L7 Envoy logic, that's probably less quick than something at the L4 level. So work stealing is a better engineering trade-off. The locks will perform better the simpler the proxy is. So number one, Envoy being complex with L7 can be to its own detriment of needing work stealing. But there's also some other reasons that we might want to care more about work stealing. So if we think about the connection pool and connection reuse, I kind of have two different diagrams depicting similar request flows here. We've got L4 with sidecars and L4 with ambient. So here we're just talking about, TCP packets and encryption. Let's say we have two Kubernetes nodes here in the sidecar model, and sidecars running with like two threads as configured. If it wants to connect to applications bar and Baz with replicas on two different nodes, it makes a total of 20 requests per second, 5 per connection. We've got 4 different connections here. If bar and Baz are the same service account, so we could also just up the replica count and not do different services. But in the Ztunnel model, we connect to Ztunnel and we could reuse that connection. Connection 4 is really kind of the crux of it here. If we look at the Ztunnel threading model, it's going to primarily connect to other Ztunnels. So here we have a sidecar that needs to create 4 connections, and that might scale very large with each pod. But Ztunnel is going to scale more per node, and each connection is going to be more aggressive. So kind of in short, the request pattern is a little different, and it's more important we can reuse connections. Does that clear?
That's really interesting. I think you highlighted an important point about in sidecar, we don't really share the connection between different applications, right? But in the context of Ztunnel, we open a new connection when there's non-exist for a particularly source and destination service account pair, right? So in your example, application bar 2 and baz 2, when they share the same service account, so it could be the same connection tunnel from the source Z tunnel, which is really cool.
Yeah, and with that connection reuse, we're saving the TCP handshake, and by leaving that open, we can really bump up performance and connection reuse with work stealing. It's another thing that we saw just in the community. Cloudflare had success with their Pingora proxy as well. I think they got connection reuse from 87% to 99 something. So there's a lot of also just real world examples where you can see the impact that this can have.
Yeah, totally. Now you talk about sidecar, right? What about gateway? Any special characteristic of gateway make work stealing not so interesting for the gateway?
Yeah, so I didn't do a separate diagram because the reasoning and rationale is pretty similar. The reason why Ztunnel it matters more is because we can reuse the connections, and the targets are mostly Ztunnels and things local to the node. But in the sidecar model, we could have tons of connections to tons of pods. It scales per pod rather than per node. And the gateway is very similar. The request pattern is very much the same. In fact, it's also a good reason to keep Envoy as L7 waypoint, because if you think about the waypoint proxy enforcing L7 policy and ambient, it basically is a gateway. It's basically a service account specific gateway that applies policy on egress or ingress. And so its threading model very much models sidecar or regular gateway, which works pretty well with Envoy.
Yeah. And I guess the other thing I just thought of, right? So gateway, you can potentially run multiple replicas, same as Sidecar, but Ztunnel you can't, right? So that's number one. Number two is gateway. There's no way to guarantee that gateway only process layer 4 traffic, right? A lot of gateway actually does layer 7 also. So that's another advantage to continue use Envoy for the gateway. Do you agree with that?
Yeah, I tend to agree.
Okay, cool. Because I just thought about that. Let's see what else. Okay, there was Neeraj had a blog, and I personally kind of asked you about, how what's mentioned in the blog through an Envoy filter to balance the connection different than what we are trying to do here with work threading model.
Yeah, so there's there's a lot of different angles that we can talk about. We spoke a lot about work stealing and connection reuse. I'm sure those of us who have spent a lot of time working in Envoy have thought about how can we just distribute the work equally, and is that going to be enough? Is it a similar problem? Is it a different problem? It really is kind of tangential, and we do obviously want to balance our connections. But to highlight the blog that you're talking about, that Neeraj had written, he kind of had identified this performance problem that you can see in the left here. Like we said before, each worker has its own copy of memory and serves requests. Based on downstream client request patterns, you can see that it's possible that they all end up on the same worker thread. And then he was noticing that this caused a bottleneck in the blog linked before. And the solution here was to go ahead and do a collect connection balance Envoy filter on the inbound and outbound listener sidecar. And the result of this is that if you can see the metrics here, you would get connections distributed equally, and that vastly improved performance. And you see improved performance and connections, and you might think naively, this is the same problem, or we can just do this. But kind of just going back to what our ideal state is, we want to avoid the cost of initiating a connection. We want to reuse ones that are already open. We don't want it to, if we distribute this equally, we're going to need to initiate a connection perhaps to the same destination numerous times when we might be able to get away with doing it once, if we could share a thread pool. So it's a little bit different.
Yeah, that makes sense. So this is more for new connections versus reusing the existing connection and then kind of steal the job and finish it up. Yeah.
Yeah, exactly. If we can reuse, yeah.
Okay, cool. With that, I guess we're going to talk about the Rust-based Ztunnel. So as you all know, Kevin, I'm going to remove your stream here, and I'm going to quickly share my screen a little bit. So I'm going to first share the browser first. Yeah, so as we mentioned, the Rust-based Ztunnel is a repo in Istio.org, and I actually just got it built myself. So one key caveat is if you're using Mac OS, which I am, you won't be able to build the FIPS stuff for Linux x86-64. So make sure you disable the FIPS. And then there's actually really good instructions on here too. So you can follow the instructions and how to also deploy ambient using the Rust-based Ztunnel. So the instructions are out there. With that, I'm going to see if I can show a demo. Let me share a different screen. And Kevin, feel free to ask me if there's any questions that I didn't thought about. So I'm going to pray the demo gods. Hopefully everything works.
I was
Can you
about
see
to
my
say the same
terminal?
thing. It's live. I can see the demo.
All right, great. Okay, I'm going to change the window a little bit smaller. All right, so let's go ahead and get started. So the first thing I want to say is I have a Kubernetes cluster. So it should be 2 nodes. I have ambient worker 2, and also a control plane nodes. And in my cluster right now, I don't have anything. Actually, let me launch the K9S on here and also on here. So I have a little bit more context. All right, so and in here, I am going to jump into here. The first thing I'm going to do is I already have the images built. Like I mentioned to you, I was following the instruction to build different images. So this is the raw-based Ztunnel. I built it locally on my Mac. So the first thing I'm going to do is actually push these images to my registry in the kind cluster, so I can use them to install Ambient. Now, the next thing I'm doing is install Ambient. So I'm in the experimental branch, and I've set my hub and tag to use localhost 5000 and with the ambient value as the tag. So notice here I'm specify using Ztunnel as the image. So I'm using the Ztunnel, Rust-based Ztunnel image I just built yesterday. And I'm also continue to run the ambient profile, which essentially enables Edgebone for the proxy and the gateway. All right, so Ambient is installed with the Rust-based Ztunnel. So what I'm going to do here is on the first one, I'm going to show you. So I have the Ztunnel installed, right? So it's the Ztunnel is a daemon set, like we mentioned before. So it's installed on one replica on each of the worker VM, which I have 3. I have Istio control plane and gateway installed. I have also the CNI installed. So I don't have any application at the moment. So everything is just plain installation of Ambient. So the next thing I'm going to do is label the default namespace to be part of Ambient. You could potentially do it after your pods are deployed, but I think the current codebase have a little bit issues, so I might just doing label first before I deploy app, as we need to work through that issue upstream. So I'm going to deploy the demo application, which is the sleep and the hello world. So hopefully on here, we should, if I jump into just show the default namespace, hopefully I'll be able to have them up running. Maybe let me double check this. Wonder if I have the right, okay, so wonder why is this, maybe I need to slash at the end. All right, that was it. Okay. Okay, so I have the demo application coming up now. So it's basically Sleep and Hello World version 1 and 2. You guys probably are familiar with that if you've seen Christians talk about ambient. So essentially, Hello World version 2 is running on the same node, which is Ambient Worker 2 as Sleep, which is our client. And the Hello version 1 is the cross node, right? All right, so I have these deployed, and let's see, it's still trying to come up, so let's give them a few seconds. All right, almost there. Okay, so the next thing we want to do is we want to be able to call the sleep, hello from sleep. So Now it's his version 2, so that's the same node. I his version 1, that's a different node. Now, if we go to the Ztunnel logs, right? So we should be able to see some logs that's interesting. So for instance, this is Hello version 2. I'm sorry, Hello version 1 Ctunnel, which is on Ambient Worker, right? So if we go to that log, you will see a connect request. Okay, so first of all, you'll see the certificate, right? This Ztunnel can represent hello world, and you'll see the Edgebone connect request to send to hello version 1. So there's that. And if you go to Ztunnel, I guess we should have another Ztunnel ambient worker. Okay, ambient worker 2. Yeah. So if you go to this Ztunnel log, let me send some traffic. So it sends to hello version 1, right? So yeah, you can see it's trying to send to the destination 1.4, which is hello version 1 using Edgebone. So yeah, it's established the outbound traffic to the destination Ztunnel. Any questions, Kevin?
No questions from me here.
Okay, great. Let's continue then. Now, the next thing I want to do is figure out the pods for Ztunnel on the first worker VM and also the pods for Ztunnel on the second worker VM. And the reason we're doing that is we're going to look at the config dump, right? So similar as Envoy, you can also do config dump for Rust-based Ztunnel. So what we're doing is we are dump the config dump of Ztunnel for the node on the first node and second node. Now, if we do format the config dump, you can see this is actually readable, right? I remember when it was Envoy-based Ztunnel, there was literally like 3 to 5 people can read the configuration because of the hoops jumping through the internal listener. It was multi tenancy, it may represent different identities. It was really, really hard to read. This is actually human readable, right? So because it's essentially, this captures the entire Ztunnel config. And you can see it has the workload information, right? So this is our hello world. It speaks the Edgebone. It's not Edgebone native, which sidecar should be Edgebone native, because this is leverage Edgebone through the Ztunnel. So this is hello version 2, and it also have some of the Istio system pod, and this is our sleep. And you can see some of these system pod, they're not in ambient, right? So they don't speak Edgebone, they can only speak TCP, right? Even though Istio D is there, and we also have Ztunnel and Istio ingress gateway. So all these are speak plain TCP. Besides the workload information, you will also see workload to WIP, right? Kevin early on talked about part of the challenging with the Envoy-based Ztunnel is to be able to resolve from the WIP to resolve to the actual endpoint. So it's important for us to understand how the WIP maps to the workload, and this map would show you that information. In addition to that, there's also a map for WIPs, how from a WIP you can map to how from a WIP, I think you can map to the actual endpoints. And I think that's pretty much it. That's important. And then just typical version and config, right? Is this a lot simpler from the Envoy-based config, Kevin?
Yeah, it's infinitely simpler. I think even the best case Envoy config, this is probably simpler. It's one of the many
Yeah.
benefits of moving to a net new proxy. So
Yeah, I remember it was even just for like 2 or 3 app, it was like tens of thousands of lines, multiple tens of thousands of lines. Yeah. All right, so the next command I'm going to run is a proxy config and examine the Ztunnel config that we just reviewed. So this would show you a little bit easy to read format of the workload information that the Ztunnel is aware of. So you can see what we actually just reviewed in JSON, but this is a nicer format that you can see these three application deployments are in Ambient, which can speak the Edgephone protocol, and the others couldn't. All right, so there's that. We reviewed the config, we reviewed the log. The last thing we want to do is actually pull out a traffic capture. So just making sure from the sleep to hello world, we're getting mutual TLS. I believe this should be mutual TLS 1.3 upgraded connection.
And Lynn,
So
just
yeah.
one quick question, not enough of the comments, but perhaps do you mind just a quick second talking about Hbone for those who may not have heard of it before?
Yeah, so Edgebone is a new, I think it stands for HTTP Connect overlay for network environments. It's the new connection tunnel um, that's been using in Istio to connect for inter-service communication in Istio Ambient Service Mesh. So essentially, the traffic from Ztunnel to the waypoint proxy, or the traffic from Ztunnel to Ztunnel, it's going through the Edgebone tunnel, and we typically open Edgebone tunnel per source and destination service account pair, right? So if the Ztunnel sees there are existing connection between the particular source and destination, which is a sleep to hello world here, it would try to reuse that connection. And if there's nothing exists, it would create a new connection. Do you want to add anything, Kevin?
No, just that it's relatively new and brewed for the situation, and the purpose of doing an HTTP connect, I believe it's HTTP 2, and it will be HTTP 3 connect, but it allows us to pass additional metadata. So that's its purpose about the connection,
Yeah,
not just the byte raw bytes.
yeah, that's a great point. All right, so I have this thing in, we're using this debug container, right? Attach this debugger container to the Ztunnel pod on Ambient Worker 1. And we're going to use term hack to capture the traffic on ether 0. Now, the next thing I'm going to do is send in some traffic. So, come to a different terminal just so we can send some traffic. So hello version 2, that's the same node. So essentially, it doesn't run cross node. So because the traffic from the pod hello version 2 to Ztunnel is plain text, and also the traffic from sleep to Ztunnel is also plain text. So it's less interesting in that case. But we should have some interesting traffic now. So let's see. So for instance, all right, this is the end. So let's scroll back a little bit. So this TLS 1.2, I believe, is back to the control plane. So 29.254, that should be the Istio control plane, I believe. Istio D. I think it's the control planes. Let's see, is it service? And it's 0 to see. Yeah, so that's Istio D's control plane WIP address 254. So this is from the Ztunnel to the Istio D control plane. Remember, Ztunnel is served as XDS client. It also serves as CA client, right? So it needs to talk to Istio D, and that's secure through TLS 1.2.
And
I
that
believe go ahead.
I was just going to say that XDS is a new custom brewed workload DS. The idea is going to be a Delta workload discovery service, which would help Ztunnel scale further as well, like an on-demand set. Rather than sending larger resources, we can send a customized special small workload discovery service with just what we need. And if we can do it with deltas, then the request load on pod endpoint changes are very small. So this
Yeah,
just helps scale.
that's a great comment, Kevin. So yeah, so basically the workload configuration that we reviewed together early, the config dump, right? So those are the configuration, XDS and workload configuration the Ztunnel gets from IstioD. Yeah, it's much reduced, and plus Delta is, I think Delta is even implemented.
It's not existing yet, but it's planned to do Delta and on demand.
Okay, because I hear from John that might already be implemented the Delta for the Ztunnel. Was certainly not something I have tried to confirm yet. Okay, so you see the request to /hello comes in, right? So that's from our source 1.2 to destination 1.4. So if we go to the pause, I can type. So 1.4 is the hello word, right? So that's the destination. And the source is 1.2, I suspect is the Ztunnel. Yeah, so it's the Ztunnel on the ambient worker. And you'll see the application data. So this is from 1.4 to 2.3. So 1.4, which is okay, 1.4 is version 1, and 2.3 is the ambient worker 2 to the Ztunnel, right? So that's the most important pass because that's cross node and that's encrypted using TLS 1.3. So very cool. Basically, you get automatically mutual TLS traffic across different nodes just by adding your paths to ambient. I think that's the demo I have. Kevin, is there anything else you think might be interested showing?
I think you did a great job covering this, and I think the audience does as well.
Okay, great. Well, folks, if you guys have any questions, we would love to, you can send them through the comments. We haven't seen any questions, but we really appreciate you guys join and send us your questions.
Yes, thank you for joining us.
Yeah. Well, if there's no questions, Kevin, where can folks find you if they have further questions?
We've got just drop into the public Slack, Solo Slack. On all any of our docs, there should be a link at the bottom. Believe it's just Solo-Slack. I'd have to look at the link itself. But anyways, we're very active and responsive in the join the community and chat there. I'm also in the Istio Slack if you're in that, and under the name Kevin Dorosh. So just drop a line. I'm happy to chat about whatever's on your mind.
Okay, great. I want to take a minute to thank you, Kevin. Thank you so much for getting on the show, and it's been really nice chatting with you. I feel like I personally been learning a lot from you on work stealing, connection rebalance, be able to steal jobs, and Envoy threading model. So thanks for all the education you have on me and on our audience. So folks, if you like this, please give us a thumbs up. And if you have any future questions or any topics you want to see for any of our future show, please open up a GitHub issue or send us a request through Istio or Solo Slack. And with that, I would say I wish everybody a happy holidays. Our next episode would be in the new year. So see you in the new year. Thanks so much. Bye now.